Hello there, Mr. Sutton here, bringing you the Algebra 2, Chapter 5, Quiz 2 review solutions on rational exponents and radical functions. In this one, we're focusing specifically on radical equations and also function notation, operations, composition, inverses, all that fun. For this problem, we're trying to solve this radical inequality. So first thing we're going to do is just pretend it's an equation and find out what x has to be. And we'll only reverse the inequality if we multiply or divide by a negative. Otherwise, this will remain less than or equal to. So first step, let's subtract 2 from both sides. That'll give me 15 over there. And dividing both sides by 3 now, positive 3, so we don't have to change anything. That gives me a 5 on the right side. Now to get the radical to go goodbye, we need to square both sides because this is a square root. So that gives me x minus 4 less than or equal to 5 squared, or 25. And then we can just add 4 to the other side to get x less than or equal to 29. Now we're not quite done. Because this is a square root, that means that the radicand, the x minus 4, has to be non-negative, has to be greater than or equal to 0. So we're also going to need to figure this out and throw it in with our final answer. So this one's pretty easy. I just have to add 4 to the other side, and we find that x has to be greater than or equal to 4. Because if it's 4 or if it's less than 4 rather, that means I'm going to be square rooting a negative here. So putting this together, bigger than or equal to 4, less than or equal to 29, we can write that as 4 less than or equal to x less than or equal to 29. For this problem, they want us to do f minus g of x, which basically means we need to take the f function and subtract the g function. So we've got the whole f function right here in red, and this other one I'm subtracting is the g function. This first parentheses I can get rid of for free, but this next one I'm going to have to distribute a negative 1 since we have subtraction. If we had addition, I could also get rid of the second one without making any changes. But distributing that negative 1 now, we have positive x cubed, positive 8x squared, plus 4x, and minus 7. And at this point, let's simplify and combine like terms. So 5x cubed and x cubed gives me 6x cubed. There's only one of the x squared terms. It's this 8x squared piece here. X plus 4x gives me 5x. And then negative 8 plus negative 7 is going to be negative 15. For this problem, I'm trying to find f of g of x, so composition of functions. So initially I need to do f of this g function, f of x minus 3. That just means I'm taking x minus 3 and replacing the x in the original f function with x minus 3. So this is going to be 9 times x minus 3 to the first power. And just to simplify that by making the exponent positive, we can rewrite this as 9 over x minus 3. And we also should make sure that we have the right domain for this one. Now, originally, x minus 3 by itself didn't have any domain issues, but with our modified function here, since if I plug a 3 into the denominator, that would make me undefined because I'd have 0 down here. My domain is going to be x does not equal 3. So this x minus 3 can't equal 0, so x does not equal 3. For this problem, we're trying to figure out the inverse of 6 radical x minus 1. So to start the process, we're going to switch x and y. So we'll write x equals 6 radical y minus 1. And then I'll go ahead and solve for y. So my next step to getting y by itself, I have to divide by 6, so x over 6. And then to undo this square root, I have to square both sides. So that gives me x plus 6 squared equals y minus 1. And at this point, I can add the 1 over to the other side. I'm also going to square the x and the 6, so that'll actually be x squared over 36 plus 1. And I'll rewrite the y as f inverse of x equals, and then x squared over 36 plus 1. Now, one thing I do have to be a little bit careful about here, since my original function had a range that was non-negative because this square root can't give me back negative values, and since it's an inverse, that means the range of the original is becoming the domain of the inverse. So since my original range was non-negative, my inverse domain has to be non-negative as well. So I'm going to have to write x greater than or equal to 0 just to add on to this thing.